Hi, welcome back to our Honors Geometry series. In this video, we're going to talk about how to solve for a missing angle or a missing side length in congruent triangles. So here I've given two congruent triangles, and I need to know what are the corresponding parts. I can see this big arc here. One single arc is going to match up with this big arc. So it's all about identifying what is marked with the same exact markings. So this is 148 because it must be congruent to the corresponding part. All right, this part here has no marking. So it must correspond to the part with no marking. So I know that 5x minus y must be the same as 18. Okay. Now this part has two markings, so it must correspond to this third angle. So 3x plus y equals what? Well, shoot, I don't know what that third angle is. But luckily, I do know the triangle angle sum theorem, so I know that this angle plus these two should add up to 180. So 166, 14, 148, 18, 14, 20, 6, 7, 8, 180. Perfect. Okay. And here, typically what I would try to do is I would try to solve for one of these variables. Try to get one of the variables by itself. This one looks like it's possibly the easiest because I avoid that negative y. So I can get this y by itself by moving over the 3x, by subtracting from both sides. So y equals 14 minus 3x. And now what I can do is I can take this expression here and substitute that in for y. So 5x minus 14 plus 3x equals 18. Or if I simplify, 8x equals 32, or x equals 4. And now that I know what x is, I can take that x value and substitute that back in to either one of the equations and simplify to solve for y. So here, like y equals 14 minus 3 times 4, 14 minus 12, y equals 2. All right, we're going to have to do the same thing here in number 20. Notice I have 90 degrees and 52 degrees, which means that this angle here must be 38 degrees. And this angle here must be 52, and this angle here must be 38. So now I've got two equations, and I'll do the same thing there. I'm going to find my two equations. I'm going to try to get either x or y by themselves, and then substitute that expression back into the original equation like we did here, where I took this 14 minus 3x, and I put it in for y. And I got my equation that I could solve for x, substitute that back in, and solve for y. I would pause the video, try this one on your own, and then unpause to check your work. All right, we got 6x plus 14y equals 38, and 15x minus 8y equals 52. Now, you could also solve this like a system of equations, which at least in this case is probably easier. So 6 and 15, well, I could get 30 from 6 and 15. That's your least common multiple. So if I multiply this by 5 and this by 2, I get, well, let's make that a negative 2. 30x plus 70y equals 190. Negative 30x plus 16y equals negative 104. So then I get 86y equals 86. Kind of interesting. So y equals 1. And then I can take that y value and substitute that back in. Let me kind of separate these two. So then I would get, let's see, 15x minus 8 equals 52. 15x equals 60, and x equals 4. So you can either use the solve for one variable, substitute that back in, the substitution method, as some people call it, or you can solve it like a system of equations. Either way is just fine, and either way will get you the right answer every single problem. Check out the other video on this 4.3, and I will see you soon.